This lesson is going to look at the derivative of exponential functions, but before we take the derivative, let's look at the exponential functions that we studied in Math 30-1. So the first thing, an exponential function is a function in the form of f of x is equal to a times b to the x. So b is going to be the base of our function. And in 30-1, we looked at when the base was a value greater than 1 or where the base was a fraction, a value less than 1 greater than 0. The a value of an exponential function gives the y-intercept of the graph. It's going to give the vertical stretch factor of the graph. So for example, if we look at a function where the base is greater than 1, so let's look at the function f of x is equal to 2 to the power of x. Now, there is an invisible a value here, so a value is 1. That tells you the y-intercept of the graph. So this graph is going to have a y-intercept of 1. If your base is greater than 1, it's going to represent a growth function. And the graph of a growth function would look something like this. If we have an exponential function with a base that's a value less than 1 but greater than 0, so let's say I give you a base of x, again, there's an a value or a stretch factor of 1 in my graph, so that gives me a y-intercept of 1. But what the base of less than 1 greater than 0 represents is this is going to represent a decay function. And this is what the graph of a decay function would look like. So again, if I just changed, just to remind you of a different a value. So if I said 5 times 2 to the power of x, base is 2, which indicates it would be a growth function. This graph would have a y-intercept or a vertical stretch factor of 5. Okay, so let's look at these examples. The limit as x goes to infinity of 4 to the power of x. So this would be an example where my base is greater than 1. So that's going to represent a growth function. So it'd have a y-intercept of 1, and it would be a growth function. And it's asking as x approaches infinity, so as x gets bigger and bigger and bigger, what is our limit approaching? Well, as x gets bigger and bigger and bigger, our limit is going to approach infinity. For this one, the limit as x approaches negative infinity of 1/2 to the power of x. So 1/2 is going to be a decay function, y-intercept of 1. And what this one's asking is as x approaches negative infinity, so as x gets smaller, what's happening to our limit? Our limit is approaching infinity. Conversely, I could say, what would the limit as x approaches infinity of 1/2 to the power of x? So that would just be saying as x gets bigger and bigger and bigger, what is our limit approaching? And this would be getting closer and closer to 0. So our limit would be approaching 0. Okay, the limit as x approaches infinity of 3 to the power of negative x. So the first thing that we could do is we can think about exponent laws and make that exponent positive by reciprocating. So this would give us the limit as x approaches infinity of 1 over 3 to the power of x. This is equal to. Now there's two ways we could approach this question. 1 over 3 to the power of, and I'm going to put infinity in here. So that would be 1 over. 3 to the power of infinity would be infinity. 1 divided by a really big number is 0. So that's one way we could do this question. Another way that we could do this question is we could say, okay, the limit as x approaches infinity of 3 to the negative x, we'll make that first exponent positive. So we'll say that's the limit as x approaches infinity of 1 over 3 to the x. And then I'm just going to rewrite this as the limit as x approaches infinity of 1 over 3 to the power of x, right? Because 1 to the power of x, it doesn't matter what value x is, I'm just going to get 1. And then x could also be distributed to the 3. If I look at this is going to be a decay function. So we have a decay function with a y-intercept of 1. And it's asking, as x approaches infinity, what is our corresponding limit approaching, or a y value? And that would be approaching 0. Okay, the limit as x approaches infinity of 1.5 to the power of x, base is greater than 0, so it is a growth function. As x approaches infinity, our limit, as x approaches negative infinity, our limit is going to approach 0. If x was approaching infinity, our limit would be approaching infinity as well. For this one here, our base is less than 1, so this would be a decay function. I forget if I said if this was decay or growth. This would be a growth function. This would be a decay function here. And as we approach infinity for a decay function, our limit is approaching 0. Before you watch the other 2 videos for this lesson, I recommend doing question 5, A to I, on page 361. It's going to be a whole bunch of these limit questions. So the limit as x approaches negative infinity of 4 to the power of x. But what's going to happen is we're not just going to be asking the limit as it approaches positive or negative infinity. You'll be getting questions like the limit as x approaches 0 from the right, or the limit as x approaches 0 from the left. And you might want to have the work solutions open so you could see how I rationalized my way through some of these questions. And then when you're done, you could watch the remaining 2 videos for this lesson.